Let's now move to question B. So we are told to take epsilon to be 0. So that would imply EL is ER equal to E naught. So what that means is, let's move to the coefficients. So yeah, so that would imply this energy split is given by 2 delta, right? So this would mean the energy split is given by 2 delta, and that implies this. If we look at C1 plus, and this would mean 1 plus 2 delta by 2 delta squared, right? And this is basically with 2. Then C2 plus would be times scalarity plus by 2 delta. Now notice one thing, that is scalarity is plus is, if we go to the definition, is basically minus epsilon plus E divided by 2 delta. Now this is basically 2 delta by 2 delta, which is basically 1, right? So mean C2 plus becomes one. Now C1 minus comes out to be the exact same thing, but C2 minus, this thing has C1 plus at the front times this minus divided by 2 pi. So basically now this thing is minus 1, right? Because we have minus here and minus 1, so right. So given all this information, we can now move to answering a question where we are told that at time t equals to 0, the particle is in the state psi L. Now we have to find the probability PR for the particle to be found in state psi R at time t. And we also need to find out the probability current, which is defined as this. This is the probability for the state to be found at psi R at a later time t. So we also need to find this probability current at time t is equal to 0. So if we want to find out PR, which is the probability for this initial state to be in the state psi r at a later time t, then this PR is defined as, it's given by this. Now this is the probability amplitude. Get the probability by in the mod square. So here h kept is 1, and the complete Hamiltonian is the sum of two terms. Notice one thing, that is, we don't know how this exponent, this operator acts on psi L, but we know how this exponential is this thing, this operator works on individual eigenstates of the Hamiltonian H, right? Namely, it's acting on psi 1. I mean, we actually haven't defined what psi 1 is, right? Or have we? Let me see. Actually, we haven't. Uh, so, right. So for the time being, let's do this. We take psi 2 to be the linear combination of psi 2 plus this was the form. Okay. Let me check. And then psi 1 this thing here. If this is the case, then the Hamiltonian working on psi 2 should give us, let me see what's the energy associated with the plus sign. That is E2, right? So for the plus sign, we have energy E to the plus, which is E2. So this one should give us E2, and this one should give us E1. So we know how this operator acts on psi 2 and psi 1. So it would be better to just transform or write psi L and psi R in terms of psi 1 and psi 2. Right, so let's do that now. So in order to do that, let's let's write down like psi 1, psi 1 in terms of psi L and psi R. So for psi 1, the coefficient should be this. Psi 2 are the positive ones. Right. Yeah. And we have found out values of C1, all the CIs. Right? So plugging them in, we have following expression. Minus, yeah, this is correct. Right, so what we can do is we can take this factors to be 1 because they are arbitrary. Okay. Yeah, let's just do that, and instead of writing it down, we remove them altogether. So this is that. Now we need to find psi L in terms of psi L and psi R in terms of the psi 1 and psi 2. So do that. I mean, let's do this thing. Right. Yes. So we have found out what we were looking for. Now we need to find this quantity PR, which is and take the mod square. This thing acting on psi1 would give us deferred RA. Should be E1, right? Yeah, E1. Give us E1T psi1 is deferred minus E2 I2, and then this will be acted on by this mod square. So we know that psi1 and psi2 are orthonormal, right? I could have just used the directed transmission. Yeah, I've written it down. So if we do this thing, then we'd have here's like 2. Yeah. So we'd have 2 and mod square. So this is PR. Could simplify this expression. But should we, for the time being, let's just keep it, in this form. We still have to find out J at time t is equal to 0. Right, so let's do that in the next video.